So for the most part, anyway, we are starting by class. Andy? Class. Remember, this is I was worried about letting you sit by people you want to sit by. You ignore things that you shouldn't. Now, before we get talking about 3-1, I sort of got yelled at by the janitor yesterday because there's been garbage constantly on the floors. And or, we only have half the number of janitors that we're supposed to have. So, basically letting me know that it's going to be very seldom when things are going to be swept, picked up. This is me telling you that I don't want to have to ban drinks and food in here. So just make sure you guys pick up whatever you can. Because I don't want to have to ban things like that. I'd rather you be comfortable in class, etc. 2, where does all that green ink in the back of the room come from? No, floor.
Oh yeah, it was all over my desk that one week we were gone. And we had to clean it up.
Well, I was going to say, I noticed somebody tried to clean it up because it smeared everywhere back there.
Yeah, that was us. Because it was on our desk, so we had to.
So like, was it?
It was the hour before us. So he said it was like ouch.
Yep, okay.
Yeah.
That's what I was trying to find out is what it came from.
Yeah.
Because that's probably not going to be cleaned up since it's ink.
He said they were like throwing around the paneling of it first.
Oh, good to know.
I agree.
Yeah, because my first hour said nothing yet. They didn't know that. Good to know. Okay.
Wait till the sun knew what happened. They are, it's over for what?
I was gone for over a week. It's not like it was like a different sub most of the
It
time.
was, yeah.
I'm not blaming the sub.
Blame the kids.
A little bit. So now that we've gotten to the point where power rule, product rule, quotient rule, trig derivatives, natural log derivatives, E derivatives, you probably feel relatively good about it. Now, that's not to say a question can't be tricky and things like that, but you probably feel pretty good about how to do derivatives is my guess. Okay, well, then now we're going to introduce something to make them harder. So naturally, we can't have you feeling good about yourself in calc for too long. That's kind of the chain rule. Yeah. You guys were given the easy versions of every derivative purposefully. So I don't know if you ever noticed it, right? You only ever had a power on a variable. Or you only ever had a power on something very simple. Your equations weren't written in a difficult manner. So it's definitely easier to learn power rule. And to be honest, product and quotient rule aren't any different or harder. Like power and product are just methods to do derivatives. So power rule, trig derivatives, natural log derivatives, and E derivatives are actually the only 4 ways we know how to do it. They were all the easy versions of themselves. You never had a natural log of anything other than x. Right? Like you didn't have natural log of 2x squared minus 3x plus 1. The actual natural log portion was very simple. You also never had e to a power other than just x. The only thing you had was like a multiplier in the front. But absolutely, you can have e to a very complicated power. So you were taught the easiest versions of everything so that you learned how to do the derivatives. Chain rule is going to be basically like the full version of the question, the full version of the actual rules. Now, I don't know if it's going to be easier to try to show the weights in the packet or not. This is generally not how I introduced it. Not that this is wrong in any which way. This is the actual chain rule. Okay, but in my experience, most of the students who look at that, that doesn't help them figure out the chain rule. I would say from my experience, most of you who look at this aren't really even sure what it says. I don't know if I could be, I don't know if I'm wrong on that. You guys know what this even says? What is f of g of x? What does that look like as an equation?
You plug in g of x to f of x.
Yeah, see, that's the problem, is you guys are definitely trained on how to find an answer to f of g of x, but not to look at something and recognize when it's already in f of g of x. Right. This is an f of g of x. Square root of x cubed plus 2 is already a composite function. Yeah. This is basically already a combination of two different things, like two different types of functions. And it's, I'm not trying to say this as a bad thing, that you don't recognize that as f of g of x right away. What I'm trying to say is you need to learn how to train yourself to know when to do what derivatives, okay? If you are good enough to be able to recognize this as split apart like that, well then this formula works great. But if you look at x squared of x cubed plus 2, and you don't see it as two separate types of things, this isn't gonna help you, so. If you actually have formula sheets, like I think I've seen some of you print them out. And or, if you ever go to Barnes and Noble, or even you just order them on Amazon, they have laminated calc cheat sheets like made up already. Like they're popular throughout the years. So if you ever look at those cheat sheets with formulas, the power rule isn't what I showed to you guys. The power rule would be taking the derivative of anything to a variable power. Okay, so did I say variable power? Numeric power. A variable thing to a numeric power. The actual derivative is going to be the numeric power in the front, like we've done, and then the variable thing to the power, minus 1. But you're actually going to need to multiply by the derivative of what had the power on it. This is the full power rule. We left this part off so that learning the power rule was much easier. Like you could focus on the power rule part. Every single question we had, this was an x, right? And then if this is an x, the derivative at the end is just 1, because the derivative of x is 1. So you were purposely given ones that would work out without giving you the full version of power rule. Okay, so as you're doing the power rule, here's what you're going to have to kind of teach yourself. Whatever has the power on it, you have to take the derivative of that at the end. Power rule still works exactly the same. So here's an example. Actually, I can do the one from that previous page. What was it? X. What was the square root of what? X to the third plus 2. So I'm going to write the square root of x to the third plus 2 as a power rule problem, right? So if I'm going to do the power rule on this, x cubed plus 2 is like a u, like u substitution, because you did that in pre-calc. You can do u substitution in your head, or you can actually write it out. But if I have anything to a power, the power rule works, and my derivative works. 1/2 multiplies in the front. Whatever had the power, I'm going to subtract 1. and then I'm gonna multiply by the derivative of whatever had the power. So this stays the same. This is gonna be the derivative of whatever had a power on it. This is gonna be the full version of power. Now, obviously, I'm not expecting you to like know this off the top of your head. Like if you look at the bottom of the piece of paper in the packet, we're gonna practice the power rule on a parentheses to a power, something you actually could FOIL out and figure out the answer 2 different ways. And we're supposed to go over the fact that they're gonna be the same. But this is what the power rule should look like. Now, let's take a trig one, your favorite topic. I'll just pick a single trig one because they're all done the same way. Kale, give me one of the trig ones.
Sine of x.
Okay, definitely an easy one. I'll go with it. So sine of x. But we no longer are going to think of it as an x. If I take the derivative of sine of any angle, so instead of having x as the angle is anything. That's what the u represents. The answer is going to be cosine, like it always was, of the same angle times the derivative of the angle. That's going to be what the chain rule is. You're going to take the derivative of the outside times the derivative of the inside. That's how a lot of students like to think of it in their head. That worked up here too. Take the derivative of the outside times the derivative of the inside. Okay, let's do an actual example with a, let's do tangent. Sure, like you actually care. We need somebody to come up with a bad angle. Good, because you're on your phone.
Yeah.
What are you doing? Are you gonna try to say it's your mom again?
No, I was trying to buy a ticket for the football game tonight.
Good, that's fair.
Can't figure it out, but let me know if anyone's got the link.
Yeah, State High School League, it's not a good website. Okay, I need an angle. Give me an there we go. Give me an equation for an angle.
An equation for an angle.
Just give me an equation. Make up an equation for me.
4x squared plus
Okay.
6. Is that okay?
I've only got an hour to teach class here today.
Is that enough or no?
You were making it up, not
I'm
me.
sure that's good.
Okay, that's good. Okay, so trying to take the derivative of tangent of any angle. Now, if you are a person that likes to do u substitution, if you are a person that likes to do u substitution, and I will show you how to do that as we go along. The angle itself is kind of part of the derivative, okay? So it doesn't matter how simple or complicated the angle is, we still do the derivative the same way. The derivative of tangent of any angle is going to be secant squared of the angle but then we are going to multiply by the derivative of the angle. That's what the u prime is. So that would be what, 8x? This is what chain rule is going to look like. We are going to keep doing the same 4 derivatives we always have done. Power rule is a derivative method. Trig is a derivative method. E to the whatever is a derivative method. And then the natural log is also a derivative method. Now I purposely left off product and quotient rule because product and quotient rule doesn't actually do the derivatives. Because when you do product to quotient rule off on the side, you write f prime g prime, and you do the derivatives individually and separately. The only derivatives we know how to do are the four: power, trig, e, natural. Product and quotient rule won't be any different doing with this. They'll just be more complicated because there'll be more parts. But product and quotient are the same thing. Okay, so this is, in a nutshell, what the chain rule is. This is exactly what we did, but to me, this just never usually clicks. However, I want to point out that on the AP test, or even think of our last test we just did. Remember how there was a table with like f prime, g prime? You're going to get those same questions for this. So you do need to actually know this for certain. Because this would be how you would find chain rule derivatives from a table. Because you have to know the actual formula. All right. I'm not trying to fly through this section, because if I do fly through this section, you will be lost for the next 2 units, right? So we're gonna take our time on this one. For those that were already asking, we're gonna get as far as we can to the end of the trimester, and then take a test at the end of the trimester. That way you guys have one more score to help you out. I'm assuming that you guys would view that in a good way. I suppose you don't know until I correct the test. Sure, just skip off, no problem. Oh, you're a lot better than everybody else who was already marked. Everybody else already skipped, they didn't even come to class. 15? Yeah. So we have a Raptor time scheduled today, but we don't have Raptor time. We have to go to a Veterans Day program when Raptor time would be. So right after this hour, we go to the gym. Okay. Find the derivative of 5x plus 3 squared with and without the chain rule. Without the chain rule, we could actually FOIL this out, right? So if I decide to FOIL that out because I don't want to do the chain rule, I would make this 25x squared plus 30 plus 9. Yeah, 30. The derivative would be just regular power rule and everything. And like when I'm looking at this, the powers are just on x's. So that's why it's like the simple power rule. So 50x plus 30 plus 0. Why are these numbers gotta be so big? With the chain rule. So I'm gonna rewrite the original equation. Here, should I stand on this side? That helps. Now, when I look at this, I am specifically looking at the fact that the power is on a group of things. So if I'm going to be doing power rule, I can look at this as a U substitution. The power is on a bunch of stuff. So I'm going to do power rule like regular. Multiply the 2 in the front, subtract 1 on the power, but then I'm going to multiply by the derivative of my u, whatever the power was on, which in this case would be times 5. And if I multiply this all out and simplify it, I get that. There definitely are going to be times when you can choose how you want to do a derivative. Generally, you try to choose whichever would be faster. I mean, like that's usually the choice that most people take, right? We had a couple questions like that previously, like there were some that you could do the quotient rule on, but you could have also rewritten it as product rule with a negative power. And some of you do product rule because that's quicker for you to do than quotient. And there's gonna be lots of ways to approach things. It just depends on how you view them or your perspective. So like this one, if you take the perspective of, I'm gonna square it. Well, then you do that, and then you take the derivative. If you take the perspective of, I have something squared, then I can do power rule on that and approach it that way. That's kind of how calc is gonna work and why some people don't like calc, because it's not a, calc all you care about is getting from the beginning to the end. And there isn't necessarily just one straight way. You're going to have multiple paths that you can frequently take. Some people don't like that. The DOF and the diff. I don't think I've ever noticed that part before. Those are bolded, aren't they? DOF times diff. I feel like, I don't know, I don't like that. I feel like that's gonna have some versions that wouldn't be very family friendly. People would definitely replace F. I don't like that. We won't do that. Do you guys think you could try this one on your own? Ignoring the DOF and diff.
I tried it, but I did it.
Well, that's the whole point of practicing. Getting it wrong is okay, that's why we practice. It's active learning. Jesse, you're already done? I was hoping you could come up and put it up there. I have confidence that you did it right. This one's definitely a good example of why you don't want to always FOIL it out. Because a cube one takes a little bit of time. It's kind of annoying. It's kind of annoying. If you know how to cube in your head, that's fine. Because there's a way to write out the cube with one line. Jesse, what happened here? We can guide you if you want. You can bring up an emotional support person if you need one. Yeah. Yeah. Yes, she does. What are you doing? Oh.
Well, I did mine is backwards.
You got this. Did you want me to look at your work?
You have to simplify it more.
You did it perfectly. Yes, simplified. The only thing that can simplify on that is multiplying the negative 2x at the end and the 3 at the front. It can't simplify with the parentheses because it's got a square. Yeah, you did it right. That's all that you're supposed to do. Christian. Okay, Jesse is being brave and writing the information up there. I was hoping you could explain what's being written on the board. Where are the parts coming from?
So that 3 in the front, that's the power.
Good?
The 4x squared, or 4 minus x squared, that's from the middle part.
Okay, that's what had the power on it originally. Yep, so it stays that way.
And that's being multiplied by the derivative of the middle part.
Perfect. The squared came from,
Oh, it's subtracted.
subtract 1 from the power. What you said was perfect. The negative 2x came from taking the derivative of the parentheses, or derivative of the u. Now, this is done correctly. You would be expected to simplify these two things together. So your final answer would be at least expected to be negative 6x, 4 minus x squared squared. You cannot do anything with the parentheses because of the square.
Is it supposed
Oh.
to? Is that right?
The squared on that parentheses means that you can't work inside of it. If this had a first power on it, like our previous problem did, then you can multiply the parts and distribute. You can't do distribution if there's a squared on it. You could FOIL the inside, you're not going to be expected to. Oh, sorry, but you could. Honestly, you're not going to want to. You're going to want to leave us like this, because when we get to the stage where we're going to be working with derivatives, this is an easier equation to find answers from than if you decided to FOIL it and make it a big, long polynomial. Polynomials are actually hard to find answers from.
How did you go from negative 2x to negative 6x?
The 3 being multiplied in the front, and the negative 2x being multiplied at the end. Sometimes it's really easy for that 3 in the front to be just kind of blended and not see it.
My friends are taking my calculator. My friends are taking my calculator.
Okay. Why do you look like you're like making this up or something? Like, you look like I'm not going to believe you.
I just don't want to be like super loud.
Oh. Well, you came up and talked in front of the computer that's recording it, so. We go to 15? Here's me staring at the one on the wall that I wrote at the beginning there that's all sloppy and forgetting that was the whole reason why I put it here. I kind of like this. I feel like it's probably good for you guys too, because schedule is different virtually every day at this point. Okay. Well, are you guys confident enough to try these two? Okay. Now what you're going to want to do is rewrite them into the forms that we know how to work with. We only know how to do power rule, natural logs, ease, and trace. Product and quotient are methods as well, but they're not like actual derivatives. So like say this one, you have options on what you want to do. This one, you have to rewrite it as power rule. Hold on, search pressure. Multiply by 3. Yeah. You don't have to either. Like if it was a free response question, you could leave it. But you're basically always going to see it multiplied together. Monish, I'll give you some advance notice here so that if you want to check with people around you, you can. But I feel like that first one is calling your name.
Can I bring my calculator?
Why wouldn't you be able to? Cody, how about the second one? Okay, excellent. Oh, are you writing it as an F and a G? Which is fine. I was just, okay. Yep. Now you're, it's not wrong, but you're going to end up doing chain rule twice if you do it like that. If you write it as x to the 3 halves as F, and then x squared minus 1 is G, then you would only have to do chain rule once. Because otherwise doing the derivative of x squared minus 1 cubed would be another chain rule. Yeah. Yeah, so like rewrite it first and then figure out how you want to do your F and G. Oh, okay. No, that you're just doing it right straight. That's fine. And Cody, whenever you get there, you can write it at the same time too. I was assuming you were just starting it now though. Like, yeah. Hit undo. There you go.
So he distributed the 3 and then read it out.
That is the answer. That's it. You're done. Perfect. Thank you. Okay, we haven't done the next one yet, though. Oh, okay.
Multiply just 3 out first. Oh no, his 1's just weird. For some reason I thought that was like a 7.
Oh, yeah, that's a 1.
No, this is what I said, guys. I got it right. Yes, I did. Wait, would it be?
It's too bad we're not at the point yet where you could just fling up what you already wrote down once on your computer.
And then you can put it to the front, and then once you put it to the front.
Okay, good, good. That's a good way to do it.
When you do the derivative, you multiply the derivative, what's in there? Wait, where did the 1/2 come from?
-3.
Yes.
Keep going.
That will be the 3.
Yep,
Oh, because you're doing the derivative of it.
yep. No, that's perfect.
And then how does it become 3x? 3 over 2 times 2x.
We're getting there. Yes, a lot of questions, but we haven't even finished writing stuff.
Well, yeah, but that one's finished.
Basically, you're thinking out loud,
Yeah, it helps me.
but not everybody else. Okay, excellent, thank you. Okay, now, before we talk about these problems, who should we go with? We should go with Caroline. Why is Monisha's problem done correctly, but would most definitely be marked wrong? He basically just started writing things down randomly, and we have no idea what they stand for. Yes, you know what they stand for, but the person that grades your tests would not. I'm not going to assume that you meant that that was the derivative, even though I could probably figure that out. It's really important that you actually label what you're doing. So I know on your homework you guys just write stuff down randomly. If you're the type of person that just writes stuff down all over the place, in your homework you probably want to start practicing correct notation. Cody's is definitely a good example of how it has to be written. And I say that just because if you notice he wrote f of x first, and he rewrote the original equation. So by it being labeled f of x, I know that he didn't do a derivative yet. I know he was just rewriting it. And then the next line that says f prime tells me he did a derivative. So like on Monisha's, I knew what you were writing because you were kind of speaking out loud, et cetera, et cetera. But on a test, you would have to label your first one f of x because you didn't do anything yet, you just rewrote it. And then the next line would be f prime. That would tell me you did the derivative. And then just kind of keep labeling things.
For B, how do we know that the original equation and the first f of x that is written is the same thing? Like, how can you change that from division to multiplication? You know that oh, never mind, wait, I'm dumb. Got it.
Hey, glad to help out.
Just had to say it out
So
loud to
you're
realize
just-
my mistake.
You're just saying if we didn't write that on the AP test, we get marked off, right? Not like the last test?
Next test.
Okay.
The last test, the last test I'm definitely giving grace on because I was gone for a week, so it would be difficult for me to cover a lot of the details that you needed to make sure to do. So no, I'm trying to grade accordingly to what you might have been missing that I would have talked to you about.
Also, I don't get what she just understood.
Okay.
So on A, I'm confused how you got to the 3 halves as the power, because I thought when you multiply powers, you just add them.
When you multiply two of the same bases,
Oh,
you add their powers.
got
If you have a power to a power, you multiply them.
it.
I'm going to go up, Ellie, I'm going to go up there and explain them and show them. That's why I was just falling out.
With the -7, when you change f of x, like you change it, so it's simplify it, would that be part of like the u?
The u would be 2x minus 3.
So would that be -7?
No, the -7 is a numeric multiplier. This problem would be the same with or without that, because your -7 is still just part of your derivative. So anything, yeah, just a numeric multiplier won't ever affect how you approach it. Okay, first one. Was rewritten as x squared minus 1 to the 3 halves so that you could use the power rule. Because the way it's written over here, the square root of x squared minus 1, 3, well, there's a power on the inside, but the square root isn't written as a power, and so there's not really a derivative for a square root specifically. So this was basically in his head. He wrote it as x squared minus 1 cubed to the half power. And then when you have a power to a power, you multiply their powers. So that's where the x squared minus 1 to the 3 halves came from. I think some of you do this differently in your head, and if you do, that's fine. Basically, top number is power, bottom number is root. There's different ways to view it. And then x squared minus 1 was considered like the u for u substitution. You've got something to the 3 halves power. And so I would take 3 halves in the front, keep the same item, subtract 1 from the power, multiply by the derivative of what you did the power rule on. And then you simplify it to there. Come on. Okay, which part did you say you missed? I can't remember.
How for B,
Oh, it was on B.
yeah, for just how he rewrote it.
Okay, on B you have different methods you can do. Cody decided to take the denominator, bring it up to the top, and write it as a negative exponent.
Oh, got it.
And then by doing that, he was able to do power rule / product rule, whatever you want to think of it as. If you decided to leave the problem like this to start with, you can do the quotient rule. And if you did the quotient rule, you would still have the exact same answer at the end. So no matter which way you try it, it's fine. Whoa.
Goodness.
Nice.
Well, we did a big downgrade here.
Can we do this?
I know, I'm sure you guys wrote, oh, that was about too bad, huh? I'm sure you were okay with scatter plots. Your final answer for this problem could be written multiple ways. Your final answer could be written as 28 times 2x minus 3 to the negative third power. And if you want to leave that, that's fine as an acceptable final answer. If it was a multiple choice style problem, it would most definitely be this one, which would be a no negative powers in the final answer. That's pretty much what multiple choice requires, no negative powers in the final answer. however you want to write it is fine. But just knowing the fact that suppose I should go, the 14, hey, what? Okay. The 14 and the 2 should go together. For the most part, once you train your brain to think of a parentheses as just this object, and try to think of this, like, when I look at this problem, I don't even look at the x squared minus 1, I just look at a parentheses to the 3/2 power. So then in my brain, I do power rule, 3/2 times something, subtract 1, and then I take the derivative of the something. So you definitely have to train your brain to think and view things differently. Okay, I knew I wasn't gonna get through the whole section, but yeah, go ahead.
Dave, can you quickly go over F?
F?
Yeah.
A later one or something?
Yeah, it says this now.
How would I start?
No, because I was doing that Monday.
Okay.
I mean, very quickly if you want, this should be thought of as cosine e to the 5 theta to the 3rd.
Okay, thank you.
What about that one? You've got e to the power. I just wanted to get started today. I'm definitely gonna go over this on Monday. There's a lot left to the section. I wouldn't even start the homework yet, because you're gonna absolutely run into all the homework mixed together, and so you'll probably get confused, but if you wanna try it, you can. You don't need to start the homework yet. Yeah.
I think this is a Schoology issue, because I've turned all of my